Alrighty, okay, so moving on to question 2. Question is sine of x minus pi over 6 is equal to negative 1/2, and we're trying to find for what values of x this is true when x is greater than or equal to 0, but less than or equal to 3 pi. So, I'm just gonna kind of write out our 5 steps here at the top of the paper, because this question is a little bit different from what we saw with the last one, but using the 5 steps, I just did it myself, and makes it pretty self-explanatory what you're working with, but write them out up here. So step 1, remember, is identify your argument and your interval. Step 2, identify your unit circle reference angles. Step 3 is adjusting your interval to match the denominator of those angles, so match your angles, and whatever is being manipulated in your argument, you want those to match. So step 4 is add, subtract 2 pi. So 1, you're going to add and subtract 1 full unit circle rotation to find all possible angles. And step 5, solve for x to find final solutions. Put an exclamation point there because you made it through. Okay, so step 1 again, I'm just gonna write these out on the side so you know what each step is when I work down the page. So step 1, identify your argument and your intervals. So our argument for this equation up here, for this problem, our argument, remember, is going to be whatever our angle measure, whatever is filling in to represent what our angle measure is. So where this would usually be like theta, we have this written. So that's what our angle measure is. So for our argument here, we have x minus pi over 6. And our interval is just going to be, for right now, before we get to step 3, our interval as it's given to us, 0 is less than or equal to x, which is less than or equal to 3 pi. So that's step 1. So we know what we're working with here. We can move forward with what we've got. So step 2, identify our unit circle reference angle. So this is where this number becomes important, because we have to find out for what values of our argument that this statement is true. So if we're looking for where sine is negative 1/2, this is the same as the previous problem, but we can just kind of go back and look. So we're looking for where our sine, our y values are negative again. So we're going to be working in this half, like these are our axes. We're working in this half, and we're going to look for negative 1/2. So we see that at 7 pi over 6. So we're going to write that out. And that was 7 pi over 6. And to find our second one, we're going to look in this half again, and look over here in this quadrant, quadrant 4, and find that 11 pi over 6 is the angle measure. That's what angle, the angle at which sine is -1/2. So we want our argument to be equal to these angle measures in order for this to be true, based on what's present on the unit circle. Okay, so step 2, check. Moving on, step 3. To adjust our intervals. So this is where this problem kind of gets different from the first one, because if you look at our argument, we're subtracting instead of multiplying it by a value to kind of switch up our x value. So the way that you do that is, instead of multiplying each value by whatever we were multiplying x by, we're just going to subtract each value by whatever we're subtracting from x. So each value is going to be reduced by the same value here, and that's how we're going to kind of adjust and account for that within our interval. But again, make more sense when I write it out here. Just wanted to let you know where we're going. So copy down our interval. This is what we were given. That's what we're starting with. So our first transition here is to account for our denominator, and to do that we're going to multiply by 6 over 6. We're going to multiply by 1, but with 6 to get 6 in the denominator. So because remember, that's what's in our reference angle denominator, and we want to be able to easily compare our future angles with our interval. So that's what we're going to do, is get 6 in our denominator for our interval. So 0 times 6 over 6 is going to be 0 still. X times 6 over 6 going to be 6x over 6. And 3 pi times 6 over 6, oh, I'm writing that out, is going to be, sorry about that, 18 pi over 6. So this is what we have. And I know I didn't do it in the previous problem, but if you want to, well, I'll get to that after we do our second transformation here. Okay, so we've accounted for what's in the denominator of our reference angles, so we can compare those. So now we have to account for this argument here, what we're doing to x. So in order to do that, as I said before, you're just going to do to every value what the argument says you're doing to x. So in this case, our argument says that we should subtract pi over 6 from our x value, so we're going to subtract pi over 6 from all of these values. If it were to say x plus 3 pi over 4, we would add 3 pi over 4 to each of these values. But for this case, we're subtracting pi over 6, so we're going to put over here that we're subtracting pi over 6. So 0 minus pi over 6 is negative pi over 6. 6x over 6 minus pi over 6 is going to be 6x over 6. And I'm just going to leave these separate, and I'll kind of follow up with that after. So that takes care of our x value. And then finally we have 18 pi over 6, which when you subtract 1 pi over 6 gives you 17 pi over 6. Because remember, our denominators stay the same when we add and subtract fractions. So this is what we have now. What I started to say earlier is that if you want to simplify this term here, I know we said that you don't want to simplify in the last problem. If I can find where that was here. Okay. you don't want to simplify in this problem here because you want to keep this value, you wanted to keep that value over 6 so that you could compare to your reference angles over 6. So that's why we didn't simplify here. If you had wanted to simplify this back to 2x, that would have been fine. You just don't want to simplify your minimum and maximum values, because once you get those to a point where you have a common denominator with your reference angle, you want to leave that so that the point of that is to getting it to compare. But you're never really comparing your reference angles with your middle term here. That's just to represent your argument. So, I mean, it would make it a little bit clearer almost to simplify your argument middle here, because then you could see that that's 2x, and then when you're comparing, that makes it a little bit more clear that when you're finding your additional values that you're comparing apples to apples. But you definitely don't want to simplify your minimum and maximum values, because you want to be able to compare those. So going back to this problem, question number 2, again, you don't want to simplify your min and max values, as I just said. You can't simplify 17 pi over 6, so that's not really an issue here. But like I said before, you can simplify your argument, because you're never really making comparisons between your argument and your reference angles. So to simplify this would just be to get rid of the 6 over 6, because that's 1. So we're going to simplify our argument, and that gives us negative pi over 6 is less than or equal to x, because our x stays. We got rid of the 6 over 6, but our x is still there, is x minus pi over 6, because x over x is, or 6 over 6, sorry, is just 1. So you're just getting rid of, you're simplifying the 6 over 6 down to 1, so you still have 1x. And that's still going to be 17 pi over 6. So, like I said, if you do simplify the argument from after you multiply, it does kind of make it, I guess, easier for the comparisons, because you can see that, you know, this is clearly equal to this, so you want whatever is equal, whatever angle, future angles you find to be equal to this, you can clearly see. But yeah, so I guess that's kind of a personal call. You know that even if you don't simplify it, that this is going to be equal to this, because all you're doing is multiplying by 1 and then adjusting for whatever your argument is. So long tangent, if you want to simplify your argument, go for it. If you don't, that's fine too, because you know that it's going to be equal after these 2 steps over here. So, okay, long tangent, but moving on to that. So now we have our interval that's been corrected to account for the subtraction that's taking place in our argument, and we've also corrected for the common denominators that we have in our 2 reference angles from our unit circle that we've identified. So moving on to step 4 now. Up here, step 4, add and subtract 2 pi to find all possible angles. Okay, so copy these down. We have x minus pi over 6 is equal to 7 pi over 6, and I'm just going to box that like we did last time, so you can kind of easily tell the angle values from the other math that's going on. So we can start here by adding our 2 pi, and this is kind of the same because we have the same denominator as we did in the previous question. Our 2 pi value is going to be the same, because when we multiply that by 6 over 6 to get our common denominator, we get 12 pi over 6. So that's what we were adding in the last equation. It's not always going to be 12 pi over 6, but it just happens to be 12 pi over 6 that we're adding, because our denominators are the same between this problem and the previous problem. So we're adding 2 pi which is in the form of 12 pi over 6 here. And when you add 12 pi over 6 to 7 pi over 6, you get 19 pi over 6. Box that because that's an angle measure. And when we compare that to our interval up here, we see that 19 pi over 6 is greater than our maximum possible value of 17 pi over 6. So we automatically know that even after adding 2 pi once, we've gone over our maximum level. But notice that we have a negative value here. So that does mean that we can go below 0 for our angle measures. So I'm going to draw a little arrow here, and so we can subtract here to see if this would give us a possible answer. And we're going to subtract 2 pi again. So we've been adding one rotation. With subtraction, we're taking away one rotation. So we're trying to get smaller and possibly negative angle measures here. So that would just be rotating the opposite way around the unit circle. So when we subtract 2 pi, when we subtract 12 pi over 6, here we get negative 5 pi over 6. Box that. That's kind of separate. But we get negative 5 pi over 6. So when we compare that, we see that that is also too small. So negative 5 pi over 6 is below our minimum value here. So we can also kind of X that one out. And with that, we've kind of found all of the possible angles that can come from our 7 pi over 6, which is just 7 pi over 6, because when we added 2 pi, when we went forward a rotation, that angle measure was too great, and when we went back a rotation, that angle measure was too small for our interval, so we kind of just move on. So the other reference angle that we identified was 11 pi over 6, so box that. When we add 12 pi over 6, add 2 pi, add a rotation, we end up at 23 pi over 6. And when we compare that to our interval, same problem as we had before, we're already outside of our maximum angle measure. So we know that that can't be a solution, and we know that any further values beyond that can't be a solution. So what we're going to do is take our 11 pi over 6 again, and because we have negative values, we know that negative numbers are possible, so we're going to subtract here. So we're going to subtract our 12 pi over 6, rotate the other way, rotate back one unit circle amount, rotate back 360 degrees or 2 pi radians. And when we subtract 12 pi over 6 from 11 pi over 6, we get negative pi over 6, which when you look at your interval is a possible answer because this is less than or equal to. So it can be equal to negative pi over 6, and that's what we have. So from this, we've identified 3 possible angle measures that fall within our given interval that make this statement true. So moving on again to, I'm going to need a new piece of paper. Step 5. Moving on to step 5, our final step is just to solve for x, to treat all of these angle measures like individual problems, solve for x, and get our final solutions. So I'm going to copy down the angle measures that we found in the last step. So we have x minus pi over 6 is equal to, found negative pi over 6, 7 pi over 6, and 11 pi over 6. And I just wrote those in numerical order, in increasing order, just because it's nicer, and I'm OCD, so it makes my brain happy. So for each of these then, not x equals, what we're trying to get to, x minus pi over 6, set that equal to negative pi over 6. And to solve this algebraically, you're just going to add pi over 6 to either side. These cancel, and you're left with x equals 0, because those cancel as well. So our first solution, our first known angle measure that works is 0 radians, 0 degrees. So that one's good. So we have x minus pi over 6 equals 7 pi over 6 for our second equation. When you add pi over 6, you're left with x equals 8 pi over 6. Shouldn't have circled that. When it comes to your final answers, in our last problem, all of our final fractional answers were already in simplest form. In this case, this can be simplified. So we're going to simplify it even further to 4 pi over 3, because you can take out a factor of 2 from both your numerator and your denominator. So divide both by 2, and you get still whole numbers for your numerator and denominator. And for our last problem, x minus pi over 6 is equal to, cross that off, 11 pi over 6. I'm going to add pi over 6 and get that x is equal to 12 pi over 6. And notice, again, we can take out a factor of 2. So that's not your final answer yet. You got to simplify. So if you take out a factor of 6. So if you divide both the top and bottom by 6, you get to 2 pi. So our final solution set is that x can equal 0, 4 pi over 3, and 2 pi. Yeah, and if you have your unit circle, you can always go back and check this. Just kind of like fill those values into the original equation here. So like plug 0 in for x, plug 4 pi over 3 in for x, and then just solve what's in the parentheses. So if I was to do this for, say, 4 pi over, let's do an easier one. So if I was to check my answer of 0, let's say, and I plugged in 0 for x. So I'm going to solve what's in here. So 0 minus pi over 6 is just pi over 6. And then I can go back to my unit circle and see if that's true. So that's our solution set for problem number 2. So yeah, hope that makes sense. If you have any questions, feel free to ask. I'm going to move on to question 3.